study of science with Rahul Kesherwani. Today I will start the how we fill the atomic orbitals present in an atom. So there is filling of orbitals have three laws, three rules. First one rule is the Aufbau principle. Second rule is the Pauli exclusion principle. And third one is the Hund's rule of maximum multiplicity. Maximum multiplicity. So firstly we discuss about the first rule, that is the Aufbau principle. So let us start what is the Aufbau principle. According to this, when we fill the atomic orbitals, then what will happen? According to this, in the ground state of atom, in the ground state of an atom, electrons are added progressively to the various orbitals, in increasing order of their energies, starting from orbitals having lowest energy. Means when we fill the orbitals, then we always follow the rules. Firstly, you fill the electrons in the lowest energy orbitals, then in increasing orbitals, increasing energy of orbitals, right? So for this, Aufbau summarize all these principles by a pictorial diagram. Have one subcell, that is 1s. M is equal to 2, have two subcell, that is 2s and 2p. M is equal to 3, have three subcell, 3s, 3p and 3d. Similarly, n is equal to 4, 4s, 4p, 4d and 4f. Similarly, n is equal to 5 have subcell, but here only consider only 4, but this have 5 subcell, 5s, 5p, 5d and 5f. Similarly, n is equal to 6, 6s, 6p, 6d. n is equal to 7, that is 7s and 7p. Right? So this is the pictorial diagram to summarize the Aufbau principle. We start from the 1s, then 2s, then 2p, 3s, 3p, 4s, this and this. So starting from 1s, then 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, 3d, 4p, 5s. then 4d, 5p, 6s, 4d, 5p, 6s, then 4f, 5d, 6p, 7s, then 5p, 6d, 7p, 5f, 6d and 7f, and so on. These have lowest energy. Then the energy of orbitals goes on increasing order. So these are the energy orbitals which is increasing order. So when we write the electronic configuration or filling the atomic orbitals, we follow the rules of this, which is given by the Aufbau. So let's take some example to write the electronic configuration of the elements, right? If you want to write the electronic configuration of hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, then you have only one electron, right? One electron, so starting from the 1s. As you know, in case of S have only one atomic orbitals, P have 3 orbitals, D have 5 orbitals, and F have 7 orbitals. Right? Second rule, that is Pauli exclusion principle. According to Pauli, in an atomic orbital, maximum 2 electrons are present. Means in an atomic orbitals, maximum 2 electrons can accommodate. This is called Pauli exclusion principle. Means each atomic orbitals accommodate only 2 electrons. So according to Pauli exclusion principle, S have maximum 2 electrons. So S have maximum 2 electrons. P 1, 2, 3, 4, 5, 6, that is 6 electron. In case of D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maximum 10 electron. In case of F, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. That is maximum 14 electron can accommodate in F subcell F orbitals. In case of S, maximum 2 electron. In case of P, that is 6 electron, and in case of D, that is 10 electron, and in case of F, that is 14 electrons. Right? So this is the second principle regarding the filling of electrons in an atomic orbitals. Now the third, that is the Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. In simple form, Hund says that if you have more than one electron, to fill in atomic orbital, firstly you fill the electrons in one direction and the remaining electron in opposite direction. Means if you have more than one electron, then firstly you fill the electrons in one direction in orbitals and then in opposite direction. Then in opposite direction. Let's see what is like as if you have 4 electron D4. As you know, D have 5 orbitals, 1, 2, 3, 4 and 5. So you have 4 electrons. Firstly you fill in the one direction 1, 2, 3 and 4. If you have D7, then in case of D7, 1, 2, 3, 4, 5, you firstly fill in the one direction, then the remaining electron in the opposite direction, 6 and 7. This is the first electron, second electron, third, fourth, fifth, and this is the 6th electron and this is the 7th electron. In case of F13, then F have 7 atomic orbitals, 1, 2, 3, 4, 5, 6, 7. Firstly you fill 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So this is the F13 to fill in the orbitals. If you have P5, then P have 3 orbitals, 1, 2, 3, 4, 5. So this is called Hund's rule of maximum multiplicity. Now what is the Hund's rule? According to Hund's, when more than one atomic orbitals available, when more than one atomic orbitals available having equal energies, then filling of electron firstly takes place in parallel sign, then pairing in opposite sign. Opposite sign. Like as D8. When more than one atomic orbitals available having equal energies, like D have 5 orbitals, 1, 2, 3, 4, 5 orbitals. They have same equal energies. Then the filling of electron firstly takes place in parallel sign, means in the same side. You have 8 electrons, 1, 2, 3, 4, 5. Then 6 opposite sign, 7. This is pairing of electron takes place, 7 and then 8. So this is the Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. Now write the electronic configuration of some elements according to the Aufbau, Pauli and Hund's rule of maximum multiplicity. Now the electronic configuration. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You write 1s1, then 1s2. Because S have maximum 2 electron. Now lithium 1s2, S have maximum 2 electron. Then you goes to the another orbitals 1 after 1s there is 2s, and you have only 3 electrons, so then firstly you fill the 1s orbital, then the remaining electron in the next orbitals having higher energy. In case of beryllium, 1s2, 2s2. In case of boron, 1s2, 2s3. This is wrong because s orbitals have maximum 2 electrons. So you can fill only 2 electrons here, then after 2p1. And this accommodates maximum 6 electrons. So 1s2, 2s2, 2p2. Then 1s2, 2s2, 2p3. Then 1s2, 2s2, 2p4. 1s2, 2s2, 2p5. And 1s2, 2s2, 2p6. So these are the electronic configuration of some elements. Take some another examples like 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. This is scandium, this is titanium, this is vanadium, this is chromium, this is manganese, this is iron, this is nickel, cobalt, copper and zinc. Cobalt, nickel, copper, zinc. That is 1s2, 2s2, 2p6, 3s2, 3p, 2 to 4, 10, 10 to 12, 12 and then 6, that is it. And then firstly you fill the 4s, then 3d. So 1s2, 2s2, 2p6, 3s2, 3p6, that is 2 to 6, 10 electron, 10 to 12, 12 and 6, 18, 18, then 18, then 2, that is 20 and then 1. This is the right way to fill the atomic orbitals. Why we fill the atomic orbital first and then this? It is according to n plus l rule. This is by n plus l rule. What is n plus l rule? Let's see here. 4s and 3d. 4s and 3d. N value have 4, n value have 3. N value have 0 for s orbital. N value have 0, 1, 2. That is 2. Add this n plus l, that is 4 plus 0, that is 4, and n plus l, that is 3 plus 2, that is 5. Which value have less value? N plus l for 3d. So 4s have 4s have n plus l value less than as compared to the 3d. So according to Aufbau, you fill the electrons whose n plus l value is lower as compared to the other. Right? This is the first rules to clearing the concept of why we fill the 4s orbital firstly than 3d orbitals. Right? One rule is also that if n plus l have same value, then if n plus l have same value, then you fill in those atomic orbitals which have less number of n, which have less number of n, means if you add n plus l value got the same value, then you fill in those orbitals which have less value. Right? Take some example like as 2p and 3s. 2p and 3s. N is equal to 2, n is equal to 3. N is equal to 0, 1, and n is equal to 0. Sum up, that is 3 and this is 3. So this n plus l have same value in both cases, but we fill in those orbitals which have less number of n value, right? So this is the second rule to clearing the concept according to n plus l rule. Now for titanium, 4s2 3d2. But when you write the electronic configuration, you can also write these things like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, and then 4s2. Means in the sequence order, because the three cells are present at the same position. So you can also write this is in correct way. For titanium, this is in 3d2 and 4s2. For vanadium, this is 3d3, 4s2. For chromium, this is 3d4 and 4s2. But this is wrong. Why this is wrong? Let's see here. Actually, D have 5 orbitals, 1, 2, 3 and 4, and 4s have 1 orbitals, they have 2 electrons. For the obtaining the extra stability, 1 electron of s goes to the d orbital, and then 3d5 and 4s1, and here then chromium got the half filled orbitals and 4s1 like this. So in this case, half filled orbitals takes place, which is more stable as compared to the incomplete filled orbitals. I'm sorry. So the order of stability is fulfilled orbitals, then half filled, and then incomplete filled. Why this happening? Actually, this is happening due to the symmetrical first reason. Second is the exchange of energy, which is discussed in the next video. But here we describe only the electronic configuration of some element. So the correct electronic configuration of chromium is 3d5 and 4s1. In case of manganese, that is 3d5 4s2. If this got 6 electrons, then it not get the extra stability. That's why then electron is transferred into the 4s subcell. In case of this 3d6 4s2. In case of this 3d7 4s2. 3d8 4s2. In case of copper 3d9 4s2. For obtaining the extra stability, one electron is transferred from 4s into the d, then it got 3d10 and 4s1. For 3d10 4s2. So this is the concept to write the electronic configuration of element. So thank you for watching this video. Like this video, share this video also. Don't forget to subscribe this channel. Thank you very much.